In my last video I looked at getting a C version of the game Snake running on different Sinclair machines, including the ZX81, using the Z88DK C compiler. The ZX81 version was by far the slowest, and for C to be viable as a programming language for the ZX81, it would need quite a bit of optimization. The areas I thought would need optimizing were writing to and reading from the screen, keyboard input, and generation of random numbers. So in this video I'll look at writing a C program I can run on the ZX81 as a P file that will improve the speed of these areas to see if C can be used as a way of writing ZX81 programs. For output, the Snake program used cprintf. I would need to replace this. I would access the ZX81 screen RAM directly. Input used KB hit and getcha, and I might be able to use these. And random numbers used the rand function. For the code, as I'm not a C programmer, I'm going to ask Copilot for help, but ask it for code that's readable that I can call from my main program. So I've asked it to write a print@, routine, a getchar, inkeys and randomize routines. Copilot can come up with some pretty arcane code, so I persisted with it until I got code that was understandable. I can separate these methods into a C library file later and call them from my main code. So looking at the code, I'll look at the library functions first. So I've got 4 includes, ZX81, standard int, conio and ctype. And then the first routine is the print@. I've added some checks to the top of this, so I pass in x, y and the char. If the x is out of bounds, the y is out of bounds, or the ch is a new line character, then it won't print in that case. And then onto the code that's been generated by Copilot. It's looking at the RAM for the display, adding 1 onto it, and then multiplying the y by 33 and adding that together with the x and the start of the RAM to output the character, and then just a final check to make sure that there's not a new line character in there which would break the screen if I overwrote it. So that's printing, and then getting a value for a position on the screen using the x and y. Getchar, again I've got checks on x and y, and then it's using the same RAM address for the screen, and it works out the position the same way, and then returns a character. So then next, the in keys. So for now I've stuck with the KB hit and the getcha. At the moment I'm only looking at characters within the A to Z range, and then it adjusts those to the character values for the ZX81 by taking off the A character and then adding 38, which is where the characters, where the alphabetical characters start in the ZX81. And then the random routine. First of all, I've got a random seed, which I'll call first, just to kick things off, and then the random number, I'm passing in an integer. So if I pass in, say, 16, it'll produce random numbers between 0 and 15. And then this code here has been written by Copilot. This shifting is a bit beyond me in C, but I've checked that it works, and it does seem to work okay. So that's getting a random number. And then into the main, which I'll go into in a minute. So to test this out, I wanted a simple program that would call all these functions. I decided to write a program that would print random characters to random locations on the screen. If there was already a character there, it would look at if it was white on black or black on white, and flip the new character to the opposite to add a nice effect. This uses the random printout and get chirp routines. And then for the in keys routine, I read the keyboard for characters in the range A to Z, and if any of these were pressed, then print that character instead of the random character. So going back to the source, this is my main routine. So first of all, it does a randomize to start the seed off. I've got a stop flag to stop the loop. So I first of all get a random X and Y position, and then just check that, what the randi has returned back is valid, just in case there's any bugs in that. And then I'm looking at what's being pressed, getting a character. So if no character is being pressed, then it sets chirp to be a random character rather than the key that's being pressed. And then I'm checking using the get chart, checking what's on that position on the screen. If it's a new line character, then I don't want to overwrite it, so just skip out of that. And if not, it checks if the character is white on black, and if it is, then it flips the character that I'm going to print to be black on white. And then finally, providing the character's not 0, it prints the character. So that tests out printing out random characters at random locations on the screen. So compiling the program to the P file, I use the ZCC command I'll show below, and then opening this in the 81 emulator and running the program. The program prints random characters to random locations until I press a key, for example B, when it prints Bs. It runs okay and quite fast, and I think this will be fast enough for developing a ZX81 game from C. So this will open new doors for ZX81 development. For my purposes, ZX81 Basic runs too slow, but Z80 code takes too long to develop, and I already have my ongoing Caverns project. Looking at the size of the P file from the 2.5 kilobyte C file, it's produced a 2.3 kilobyte P file. This gives me quite a bit of the ZX81 16K to play with. I'm not going to write any 1K masterpieces like Dr. Beep, as these routines already take up more space than that, and won't be able to use it to finish my ZX81 version of Caverns, as I'm already pushed for space with that using assembler. But there is enough room to play with for some other fun things. If anyone's interested, I can add these routines to my GitHub. It might be interesting to compare how they perform compared to the standard Z88DK routines. So I hope that was interesting, and thanks for watching.